This is the Roots and All podcast, and I'm your host, Sarah Wilson. Join me as I talk about all aspects of gardening with some of the top horticulturists from around the world. Hello, and welcome to this episode of the podcast. This episode is sponsored by gardencourses.com. Gardencourses.com offers online horticultural training for those looking to develop their own home gardens. The latest course to be added is Create Your Garden Sanctuary. You can go to gardencourses.com to find out more. In this episode, I'm talking to Dr. Elizabeth Westaway and Matthew Adams, co-founders of Growing Real Food for Nutrition, or Grffn for short. Grffn's vision is for a world where all food is grown for its nutritional qualities using regenerative practices and made accessible to all. We talk about how the way food is grown can affect its nutritional value and how this can support environmentally sound growing practices. I start by asking Elizabeth about her background and why she formed Grffn.
Yes. So my name is Elizabeth Westaway. I'm Dr. Elizabeth Westaway, so PH Doctor. I'm an international public health nutritionist and worked mainly in the global south, coming from an emergency background into an international development background. And I previously worked for the Food and Agriculture Organisation of the United Nations on a nutrition-sensitive agriculture project. So that was in Malawi and Cambodia. And really interesting about trying to get smallholder farmers to diversify the crop production so that they could shift away from high-input monoculture cash crops for export, and then they're selling everything and then having to buy their own food. So it was during that job, a colleague from Malawi, Stacia Nordine, who's an American dietitian who's lived and worked in Malawi for years, she mentioned the word permaculture. And in 2016, I started exploring what permaculture was, and it was amazing. Loads of light bulb moments going off, linking all the different interests and sort of passions I have around public health, nutrition, public health nutrition, food security, nutrition security, and agriculture as well. And so since then, I've been trying to get permaculture, agroecology, regenerative agriculture more sort of integrated within food and farming systems so that we're actually growing nutrient-dense food. As a public health nutritionist, I want to try and reduce the prevalence of diet-related non-communicable diseases. And so it's really important to look at improving soil health. Another interest that I started looking into is, if we have to start trying to get people to change their behaviour, getting people to eat more fruit and veg, and then say if they do change their behaviour and it turns out what they're actually eating is very poor nutritionally, I felt there was something not right about that. And so I thought, well, there must be some way of measuring what's in the food, and that led me to finding out about refractometry and spectrometry. That then led me to finding out about the Bionutrient Food Association in the States, which I can talk about a bit later. And at the Oxford Royal Food and Farming Conference in 2019, I was in a session that Andy Goldring of the Permaculture Association was facilitating, linked to their Control Shift Emergency Summit for Change, which was around trying to find solutions to wicked problems. And one of those was on healthy and sustainable food. So I went into that group, and chap sitting next to me was talking about nutrient density and how to measure it using refractometry. And so we got in contact and afterwards started a conversation, and that's Matthew Adams, who and we set up and co-founded Growing Real Food for Nutrition, which we call Grffn for short. And last year, it was set up as a community interest company.
That's fascinating. So I suppose my question is, I think a lot of people would think that food is food, right? Does it vary? Can it vary? Or, I suppose a lot of people would just assume if you're eating a carrot, you're going to get this out of it, and pretty much carrots are carrots. But I'm guessing that's not the case.
No, I mean, that's certainly not the case. And I think, a lot of people, they just give that, that response of, oh, well, a carrot's just a carrot. Why are you bothering with looking at nutrient density or food quality? And just by way of evidence of this fact that carrot is not a carrot, just want to explain some of the work that the Bionutrient Food Association in America has been doing through their Real Food campaign. In 2018, they started by asking the question, is a carrot a carrot? And essentially just asked a lot of growers and volunteers through a citizen science project in America to send in samples of carrots. They also invited them to send in samples of spinach. Now, these samples were analysed, and particularly in relation to antioxidant and polyphenol levels in the carrots, what they found was very exciting. So it had over 500 samples of carrots. Most of those carrots clustered at the lower end of the antioxidants and polyphenols levels. So they were sort of, poor quality in relation to those two elements. They did have some samples that were at the higher end, and the difference between the worst value and the best value was over 200 times. So that, to just imagine that, it's sort of more or less equivalent of eating one of those good carrots was equivalent to eating 200 of the poorer carrots to get the same levels of antioxidants and polyphenols. So that's pretty dramatic. And in terms of the spinach, they looked at iron. And again, most of the values for the samples that were analysed were clustering at the bottom end. And the difference between the worst iron level and the best iron level was 14 times. So again, showing that there is variation in the same, crops. And this is really exciting to explore further.
It is. It does raise the question. I think maybe if I ate a carrot, if I say ate 5 carrots that were kind of super nutrient rich, could I be overdosing?
I mean, we are talking about sort of low levels of nutrients that are within the different carrots. But I think where the narrative is stuck at the moment is that we're, growers, farmers, stakeholders right through food supply chains, they're not even looking and they're not seemingly interested in this variation. And that, we should be looking to be growing our food so that it is maximising health through the entire food supply chain. And particularly if we're serious about maximising population health, we should be growing, the varieties that are producing, crops that have higher antioxidants and polyphenol levels, or ones that are producing higher immune properties, or higher, flavonoids as well, if we're wanting to be eating really tasty food.
And presumably that would maximise the efficiency of our food growing systems as well.
Yes, because once you know the science behind growing high quality, high Brix food, then the only way you can grow this high level of food is through healthy soil that has got symbiotic relationships between the rhizosphere of the root and the microorganisms in the soil, so that you have greater nutrient cycling, carbon cycling and water cycling. And it's the growing practice that is the key to all of this.
Interesting. So it is totally dependent on the soil. Again,
just to exemplify this, findings coming from the Real Food Campaign in the USA through their ongoing research are showing that variety is important, and also growing practices are important if you're wanting to produce fruit and veg that is high in antioxidants and polyphenols. So what they did, they looked at grapes, they looked at carrots, kale, cherry tomatoes, spinach and lettuce. Again, invited grower partners from all over the USA to send in samples of their food crops, samples of the soil in which they were grown in, did full mineral, nutritional analyses of the soil. They looked at minerals, soil biology, soil carbon, soil organic matter. They also asked the grower partners to give this biodata, metadata on varieties and also on the growing practices. And because they're interested in the link between soil health and human health, they were very much wanting to see that, what the levels of antioxidants and polyphenols were within these food crop samples. So what they found was that hydroponically grown and glasshouse, so that being like greenhouse grown crops of those samples, were below the median levels for antioxidants and polyphenols. Biodynamic certified were below the median. American organic certified was around the median. They had organic non-certified, so potentially permaculture or agroecologically produced crops, were above the median. And then the highest levels of antioxidants and polyphenols were in crops that were regeneratively grown. So that was no-till and continuous cover crops. And they also found that high nutrient density correlated well with better taste. So, that's an ongoing story, but what's coming out of that research is showing, yes, it is how you grow your fruit and veg or your grains is very important.
Yeah, fascinating. If people wanted to go and find out more, what can they do, or where can they go for more information?
Well, I would point people to the Bionutrient Food Association website. That they're a key pioneer of this link between soil and nutrition. We, as in Grffn, Matthew and myself, we are currently replicating this work in this country. We've got a group of 50 grower partners, that's growers and farmers throughout the UK, the 4 nations of the UK, trying to learn how to grow nutrient-dense food. So in the first instance, everybody is getting familiar with measuring how to do nutrient-dense food. They'll soon be doing some taste testing later in the summer as well. So there's information about that on our website, which is www.grffn.org. And we're also on Twitter at grffn_CIC. And we are producing a newsletter every couple of months. So again, if you get on our website, sign up to the mailing list, and then you'll receive a newsletter to keep up to date with what we're doing. And the idea is later in the year, we're hoping to expand this citizen science project out to more people to get involved and join us on our journey of learning how to grow, measure and promote the benefits of nutrient-dense food for better citizen and planetary health.
Just out of interest, before I let you go, are we kind of initial indications that the nutrient-rich foods taste better?
This is, yeah, they do. I mean, Matthew had, I think it was last week, he tested a pea in his garden, and he said he tasted it. It tasted amazing. And then he went to measure the Brix level of it, and it came out as excellent. So one of the metrics of high nutrient-dense food, high Brix food, is that you get a better taste. So, for restaurants, for people who really appreciate really flavoursome food, growing nutrient-dense food is a way of benefiting everyone.
Thanks, Elizabeth. Now over to Matthew to find out how he became involved in Grffn.
Yeah, so I am a mechanical engineer by trade, and I decided after about 15 years to switch career and chose to do an holistic environmental management degree. So that really began to inspire my interest in nature and conservation as I got interested in learning about ecology. I spent my year out working with the Somerset Wildlife Trust, and I did 3 months in the Amazon rainforest just to absorb myself in nature. Then my final year I got interested in deep ecology, which is a deep green environmental philosophy. And that has kind of inspired me for what I'm doing today. So having finished that degree, I ended up running a gardening charity called the Good Gardeners Association. And they were promoting no-dig, compost, organic gardening. And they've been doing that since 1966. So I ended up taking over and running that as a charitable organisation for 11 years. When I took over, there was already within the membership this growing interest around the relationship between soil health and the nutritional quality of the food that is grown in a no-dig system. So I led some research projects in partnership with the Biodynamic Association, and it lasted for 8 years, where we were looking at 23 mineral and trace mineral elements in the soil and tracking that through to the crops in response to different methods of cultivation. So that was your no-dig, and we did a single dig and a double dig. But that was a fascinating insight, which brought me into understanding a little more about this relationship between how we look after the soil and the quality of food that comes out of it. So having run that for 11 years, I moved on to become a craft cider maker, which was again working with microorganisms, because that seems to be where a lot of new cutting edge science is going on right now to do with soil health and food quality. And being a cider maker, a craft cider maker, it's all about working with those microbes. So it's just another educational kind of learning process that I was going through as a craft cider maker. And off the back of that, I then found out about the development of the bionutrient meter, which was happening in America, where they're trying to develop a handheld scanner that will be able to theoretically measure the nutrient density of food. And that's where I then, from my previous experience, I could see the value in developing such a tool. So I connected with the organizations in America developing that tool, and we're now wanting to bring that idea to the UK. So to do that, we've set up a community interest company called Growing Real Food for Nutrition, and we're currently developing projects to explore and contribute to that work.
Mm-hmm. And is that the Brix kit that people can get?
No, I'm sorry. I've just gone straight into the bionutrient meter. So if I explain then a little bit about the Brix kit, and that's the handheld refractometer, and it's currently, as far as I'm aware, it's the only method that we've got currently that you can use to give a general assessment of food quality based on this notion of nutrient density. So the Brix refractometer and using it to test food quality was an idea that was introduced by Dr. Kerry Reams, again in America, around the 1970s. And today, kind of 50 years on, the development of that using the Brix refractometer is the bionutrient meter. So the bionutrient meter is in development and is not a tool that's ready for market. So until we reach that point, the only tools available to us are using the Brix refractometer. And so we've set up a project to explore, encouraging grower partners to start testing their food using the Brix kit. And we're just pulling in some results from our grower partners right now to try and assess where the quality of food that they're growing, what their quality of food is. So that's an ongoing project that we're currently involved in right now.
Mm-hmm. So if we had a Brix kit, how does it actually work? What is it? I know what it's measuring, but how does it do it?
So actually, I'll just come back to what it is measuring, because this is important, and it's the Brix refractometer measures the total dissolved solids in a liquid. So in a plant, the liquid is the sap. The sap is extracted with a pair of pliers that we've had made up specially. So it's just a clamping device that if you can imagine taking a leaf of lettuce and folding it up, putting it under the pliers and squeezing it. And very shortly after that, some of the sap will run out from the end of the pliers, which you direct onto the prism of the refractometer. So you've now got some drops of the plant sap sat on your refractometer. So you then look through the lens of the refractometer, and you'll see when you look through, there's a scale, and it's called the Brix scale, and it runs between 0 and 32. And so the more solids you have in the plant, the higher that number will be, between 0 and 32. And that's what you're measuring. And then we can relate those measurements to a list of vegetables and fruits in what's called the Brix Tables. And those Brix Tables articulate 4 different qualities of food based on Brix measurements. And it's described as either being poor, average, good, or excellent. So if you test a carrot and it measures, I can't remember, 16 Brix, then that might be in the excellent category. And what you can expect to see from a carrot that's expressing a high Brix value is that it's potentially become has become totally resistant to pests and disease. And it will taste better, and it will have a longer shelf life. And sorry, I just want to add one last thing. What's in the sap of a plant? So most people think of it as just sugar, because that's the product of photosynthesis, which is absolutely correct. However, when you think about what's inside a plant, there are also vitamins, minerals, proteins, and literally thousands of secondary metabolites. Now, many of those nutrients are soluble, so that means they turn into a viscous liquid. And so when you're measuring plant sap, what you're measuring is the product of photosynthesis. And if that plant has had access to the correct nutrition, that relates to the soil health and the microbial community that surrounds it, then that plant will build health and a strong immune system. And it uses enzymes to convert those sugars into complex sugars, into vitamins, into proteins, into secondary metabolites. So it's a very holistic way of looking at the total composition, total chemical composition of a plant.
So there's a few things that's made me question. The first one is, if, say, I took a berry off of a bush or a plant and took that, tested that, would that maybe then be would that definitely be indicative of every berry on that plant, or could it vary?
It could vary, but you'll find that it wouldn't vary by very much. That's my experience with my current amount of testing that I've done.
Okay. And I'm guessing the other question is, would it matter when you harvested? And I'm thinking, you might need to know when the plant was at its fullest and, maybe not overwatered, for example, or what time of day, things were varied. Would that come into account as well?
Yes, it does, and it will do. And so we don't know the answers to all those at the moment, but with starting to use the Brix as a way of understanding plant quality, you can then be kind of empowered to actually investigate those problems, those questions for yourself. So, for example, if you tested, let's say your lettuce at 8 o'clock in the morning, 10 o'clock, 12 o'clock, 2 o'clock, just as an experiment to learn yourself what happens to the quality of that plant through the day, then you might see the Brix value go along a bell curve, which is in line with the amount of sun that's available. So imagine midday, the sun at the highest, photosynthesis at the highest. That could actually be a good time to crop. But it's still an open question. I don't know if that's quite right, because it may be, you find out when you actually do that test of regular recording over a day. So you're beginning to understand how a plant actually works, and so you've asked a question. I'm not able to answer it directly, but I'm saying that using the Brix kit, you can begin to understand and formulate your own answers about when is the best time of day to crop the food. You might find it doesn't matter, or you might find with certain foods it does matter.
I'd be interested to know what effect the lunar cycle had on things as well. But also, so you mentioned citizen science, and you also said that you're getting results in already. How can people get involved? What can they do if they're interested in monitoring this?
So the purpose of our citizen science project is for us to learn as a community how to use this, how best to use this tool, how best to record the information and use that information as a kind of feedback loop. And so we're in a development phase. And part of that development phase is to be able to develop a app or some sort of program where we can then open it out to food growers who are actually interested in doing this, and we would encourage that. But as a new organisation and a new project, we're not quite there yet. And once we've gone through our growing cycle this year, hopefully we'll be able to develop that side of things so that next year we'll be in a position to invite anybody who's interested to log on to the Grffn website, find out about Brix and how to use it, and join the citizen science.
So I've got another question, which again, you may not have enough data to make this assessment, but I'm wondering how likely food is from the average garden or allotment, how likely it is to be deficient in nutrients, or is this more a problem for commercial growing enterprises?
Yeah, it's a good question, because I think it's more of a problem for large commercial enterprises. That's the emerging information that's coming from the work around the bionutrient meter. And what we're looking at here is the way that in a small-scale growing operation, the grower is much more connected with the soil and the plants that are growing there. So if you're a good grower, you'll be observing the plants, you'll be giving them water when they need water, you'll be supplying nutrient feeds when you see a need, and you can respond to the plant's needs in a more intimate way. And so take that into a commercial operation where you've got hundreds or even thousands of acres, and you just physically can't cover the ground and nurture the plants in the same way. And the nutrient deficiency comes, this is my understanding as the new information is emerging, not from a deficiency of minerals in the soil, but a deficiency of the microbiology in the soil. So what's emerging is it's that all the nutrients are there, but the mechanism for extracting those nutrients, making them biologically available for the plant, the key to that is the microbiology. It's the bacteria and fungi and the whole food web, the microbial food web. So come back to your question, in that small scale growing operation, there might be a greater possibility that you're nurturing a more diverse set of microbes which assist the plant in obtaining all the mineral elements that it requires. And in that commercial large-scale operation, it could be hard to know how to do that across thousands of acres.
Thank you to Elizabeth and Matthew for taking part in the interview. I'd love to hear your thoughts on this, and if you decide to invest in a Brix kit, let me know what you find out. And don't forget you can sign up to the Grffn newsletter. Thank you for listening, and to gardencourses.com for sponsoring this episode. Now, even Dr. Bedford's melodic voice can't completely make up for the gruesomeness of this particular set of garden inhabitants.
If there's one lesson to be learnt from watching the wildlife that visit or live in our gardens, it's that, unlike us, they're not materialistic, and that their lives predominantly focus on gaining sustenance and perpetuating their species. But although this might seem a simple, basic existence, it's by no means easy, particularly in their quest for food, and in not becoming the food of others before they've managed to reproduce. So this often means that our gardens, which might superficially appear tranquil havens for all sorts of wildlife, are probably not the safest place for complacent or unwary creatures to reside in, since they'll provide a venue for many nightmarish enactments, hosting every conceivable horror from kidnap, murder and vampirism to dismembering and being eaten alive. And yet, we'll likely be oblivious to the most brutal of these whilst they're deviously and silently performed around us within the bug world. And this is certainly the case with the Conopids, a family of small to medium-sized flies that, just like many hoverflies, have evolved to mimic the appearance of small stripy wasps. And the female Conopid flies will often be seen throughout spring and summer on flowers in our gardens, where they'll be resting and feeding on nectar. However, their seemingly innocuous behaviour has a far more sinister purpose, since the flies will be biding their time, waiting for a bee to come close to their flower. Then as one arrives, the Conopid launches herself into the air and collides headlong with the bee, creating a brief moment of contact during which she prizes open part of the bee's body and deposits an egg inside. Then, in a flash, the Conopid's deed is done, and she returns back to the flowers. The unfortunate victim, though, will be none the wiser, and for a short while goes about its normal life, whilst within its body the Conopid's egg hatches into a tiny maggot. Feeding on the bee's internal organs, the maggot grows larger, and although the bee remains alive, its behaviour begins to change, spending less time foraging, and instead of returning to its nest at night, it rests alone amongst the plants. Then finally, as the bee becomes weaker, it digs itself a little grave in the soil and dies, leaving the maggot within its body protected until it emerges the following year as an adult Conopid fly, ready to begin its annual cycle again at the expense of the bees.
You can download or listen to the podcast direct from the website rootsandall.co.uk. Please also check out my Patreon, where you can make a one-off donation or take out a monthly subscription to help support the podcast. because if you enjoy the show, please help it continue. I also have a GoFundMe where you can make a one-off donation. Even a one-off donation of £1 helps, and I'll be really grateful for your support. So please go to Patreon or GoFundMe and search for Roots and All Podcast.